Hello everyone, my name is Petr Hejtmanek, and I'm from Fire Laboratory of RP11, and today I would like to present you the research project Fire Development Modeling of Engineered Wood, aka for short a Pyroboard. This project, UCIP cooperates with the Technical Institute of Fire Protection as a main partner, and University of Chemistry and Technology in Prague. This research project is supported by Ministry of Interior of the Czech Republic. It's program Impact 1, and it's quite a new project. It started almost 1 year ago in August 2019. So today I would like to present just a few conclusions or few things that we made yet. Engineered wood or wooden-based boards are used very frequently. We can see them all over the world, all over our environment, and yet wood is and wooden boards are combustible. The fire can easily turn this into this, as it unfortunately happened a few weeks ago. But what if we have some questions about this fire? What if we want to investigate where it originated? What if we want to know where the fire developed, where the fire spread? Or if we have a newly designed building, we want to verify how the fire would spread, where the fire would spread. In this case, we have generally two options. Firstly, we can do some physical experiments. For example, build this building once more and burn it once more. And if we want to be laboratory accurate, we need to build and burn more of those objects. Sometimes it's impossible, of course, and it's not effective. Because, for example, this building was a monument, was a labeled monument. So there is another option which is now being more and more used, and this is a computer modeling of this fire development. It could be an alternative, or it could be an addition to this physical tests. However, this fire modeling stands and falls on the material characteristics, the input data of materials, input data of the fire, because the more accurate data we have, the more accurate also will be the result of this model. And if we will use bad input data, then we will have a bad simulation as well. This material characteristics we can obtain from variety of fire tests of various scales. We can do microscopic scales, small scales, medium scales, or even full scales tests. The advantage of Pyroboard research program is that we use all of them. We use all the range of the scales. So we run microscopic scales with the STA, the synchronized thermal analysis. We run some tests, some small scale tests like cone calorimeter, medium scale tests, or full scale tests in the furniture calorimeter here in UCIP. Every scale has its own advantage, has its own disadvantage. I think the advantage of the project is that we run all of them, all the scales, and we plan to use the medium and full scales full-scale tests mainly for the optimization and validation of the input data. That's because the medium-scale and full-scale tests, where the boards are used, not the small pieces of the wooden material, but all the boards are used. They are used, or they are position dependent. It depends how the board stands. It depends where the fire stands. So those scales should be used cautiously, because the input data could be risky. But on the other hand, every full-scale test, every full-scale fire test is worthy. Is worthy because it gives us some data, and it could be used as input data until we have the universal material characteristics from the microscopic scales. And today I would like to focus on the full-scale tests that were performed at UCIP, because, as I said, it's appreciative data, and maybe I would like to focus mainly on the risk of the use of the full-scale tests, because they vary and they are very dependent on the boundaries. The full-scale test consists, we have at least 16 fire scenarios that will be performed in the full-scale test. In the full scale, it is designed office stand, a normal office stand with a table, with a drawer container and a bookcase. And those 16 fire scenarios consist of 4 materials that we focus on. It means MDF board, OSB board, plywood and chipboard. Every material will be tested outside the room and inside the room, and each of those locations will be burned twice. First with the burner on the left, near the left leg, and the right, and on the right next to the drawer container. So here you can see that we really burn it outside the room, and also inside, and you can see the different development of the fire. So what matters in the fire development, in the temperature development? I would say everything. Quite significant and very predictive difference shows the comparison of the test inside the room and outside the room. This is the same chipboard furniture. It is also burnt on the left, near the left leg, but on the left side there is a graph of the heat release rate and total heat release when it was burnt outside, just under the exhaust hood, and inside the room, where of course the radiation of the smoke layer that accumulated below the ceiling influenced the rapidness of the fire development. You can see that when it was inside, the fire developed much faster. The highest peak that could be seen here was obtained in 14 minutes after the ignition. Outside, this peak was in the 23rd minute, so maybe 8 or 9 minutes after. And you can see also that the peak of the heat released in such moment was much much higher. There is 650 kilowatts when it was outside, and when it was inside, it was almost 1100 kilowatts. So almost twice. When we look at the red line of the total heat release, you can see that the total heat released from the furniture was quite the same. It was about 1200 megajoules. However, again, the average value or the value computed from before of some average data, based on some average data, it was obtained in 60 minutes when it was inside, and 70 minutes when it was outside. So again, some 10 minutes lag or difference. So this was quite a predictive difference, but there are also some differences when we just moved the burner. This is a graph of the MDF board made inside the room corner test, inside the room, and the only difference was that the red line is the line when the burner was on the right, near to the drawer, and the black line is on the was near the left leg. You can, on the first side, you can see that the HRR, the heat release rate, is quite similar, but you please focus on this 3 minutes period, where again the highest peak of the heat release rate was more than 1100 when it was on the left side, and just 800 kilowatts when it was on the right side. So again, quite a big difference, and it was just because we moved the burner 1 meter aside, and this heat release rate influences the thermal temperature field around the furniture, the radiation field around the furniture. So the fire development around this furniture would be totally different. So you can see that the details matter, and if somebody wants to simulate the fire, he should be very cautious about the data, about the input data that he uses. And I hope that the Pyroboard research program will at least help to narrow down the way how to obtain the universal material characteristics, at least for the wooden products. So thank you for your attention. I hope you liked it, and I wish you a pleasant day.